Hi everybody, my name's Ian Lawson. I work at Red Hat, and what we're going to do today is give you a very quick introduction to the concept of OpenShift Virtualization. Now, for those who know, OpenShift is based on Kubernetes. Kubernetes is a technology that is actually based around containers. Containers are actually file systems with delusions of grandeur. The whole point of containers is they're designed for multi-density and multi-tenancy, and they allow for massive use of the hardware on which they run. Virtual machines are a different concept. A virtual machine is actually a machine image that's executed directly on the kernel of the operating system. So they don't really mix together. And what we've done with OpenShift Virtualization is provide a nice bridge between the two of them. So you get the orchestration of a Kubernetes system, OpenShift, and the good old-fashioned virtualization. I'm going to show you a quick diagram of how that actually works in the OpenShift cluster itself. So an OpenShift cluster consists of three things we call control plane nodes. These actually offer what's called an API. You interact with that API, and what you do is you create instances of objects. You can then change the state of those objects. These three boxes have a shared brain. It's called the etcd. When you interact with the control plane, you create objects that are stored at a desired state in the etcd. Now, whilst this sounds a bit mad, that's all you need to know about the container orchestration side. When you actually create things that are hosted in what we call containers, how it actually does it is it actually orchestrates them to things called worker nodes. And you have multi-worker nodes in an OpenShift cluster. So these are the control plane. And these are the worker nodes. When you actually ask OpenShift to create something, an individual worker node is tasked to realize that object. They're all linked together on what's called the software-defined network. So you have an internalized network which covers all of them. And that's your cluster. If you come from a virtualization background, you'll be used to things called hypervisors. And a hypervisor is an independent machine that allows you to execute virtual machines on it. It has a kernel, and you actually run those virtual machine images directly on the kernel. The lovely thing about OpenShift Virtualization is you use container orchestration to control the virtual machines. The virtual machines themselves are identical. It's standard virtualization. Those virtual machines execute directly on the kernel of the worker nodes, but they're controlled individually by a container. And you don't need to know this. When you interact with OpenShift, you simply create a virtual machine. That virtual machine is actually allocated to a worker node, and the little pod that comes up actually executes the virtual machine. The advantage of this is you get next generation orchestration of the containers, but you get standard virtualization. So if you're coming from a legacy system like VMware, all you've got to think of is the worker node is the hypervisor. Now, the advantage of going down this route is that the pods that control the virtual machines are just standard pods in OpenShift. Same security, they live on the SDN, all those things you expect from the standard enterprise way in which OpenShift offers containerization. But now you've got the ability to lift and shift existing virtual machines and execute them within the cluster, but controlled by a container itself. There are some little nuances that make it very, very interesting. And that is when you execute a virtual machine in the OpenShift cluster itself, it appears on the actual worker node, and it's controlled by a little container. That container actually provides the interfaces to push traffic into the virtual machine. And that SDN is internalized, no visibility to the outside world whatsoever. So exactly the same as containers, you can offer what's called Kubernetes service points, which actually give you port-based traffic ingress. Now, the importance of this is you can take a legacy virtual machine. Let's say you've got a virtual machine in your old system. It's running a web server. You can bring that virtual machine directly into OpenShift and execute it as a virtual machine. You can export the port where traffic ingress is in through a Kubernetes service. And then over a longer period, you can modernize that application, produce a containerized version of that web server. And then to simply change the traffic, you change the definition of the service point. And that is invisible to the outside world. So all your consumers that are consuming that application running within the virtual machine itself will suddenly be using a modernized version, which takes much less space, much better density, and you can offline the virtual machine. That is the basic mechanics behind how OpenShift virtualization works. And the key things to remember with this is, number one, it's pure virtualization. So it's VMs controlled by pods. Number two, it gives you network abstraction. Which means you can modernize these applications in your own time. So today you can take an existing suite of virtual machines, you can lift and shift them into OpenShift, and then you can re-engineer them in a more modern way, much smaller density, much less machinery needed to actually orchestrate them in your own time. You don't have to face that massive engineering effort of changing all of your existing applications. And I say that was a very quick overview of OpenShift virtualization. What we're going to talk about next is how you use a tool called the Migration Toolkit for Virtualization to automate the lifting and shifting of VMs from legacy systems into the OpenShift cluster itself.